Hello friends, today's question. Starting with same initial conditions, an ideal gas expands from volume V1 to V2 in three different ways. The work done by the gas is W1 if the process is purely isothermal, W2 if it is purely isobaric, and W3 if it is purely adiabatic. Then we have to find out the relationship between W1, W2 and W3. So let us start from the first, that is W1, which is given as that it is an isothermal process. Isothermal process, and the work done is our W1. So isothermal means the temperature is going to remain constant. So here temperature is constant. Temperature is constant. And for ideal gas, we can say the internal energy does not change. Because of this isothermal process, we can draw a conclusion that for ideal gas, internal energy does not change. Or we can say that our delta U will be equal to 0. So it means the heat supplied is going to be converted into the work. You can say heat supplied is converted to work, which in this case is represented as W1, and we can write that our W1 will be equal to nRT log of V2 by V1, and we are given that the volume changes from V1 to V2, so we can presume that V2 is greater than our V1, so their ratio V2 upon V1 will be greater than 1, and this gives us that I think this should be natural log, not natural log. So from here we can say the value of this natural log V2 by V1 will be coming as positive. And in this case, the work done W1 is, you can say, moderately high. W1 is moderate high. Now let us discuss the second process, that is our isobaric. Isobaric process. And in this case, the work done is given as W2. And isobaric means pressure will be constant. Pressure is constant. Therefore, we can write that our work done will be, which is given as W2, will be our P, V2 minus V1. And this work done, that is W2, is slightly greater than W1. We can say this work done, that is W2, is greater than W1 for the same change in volume. For same change in volume, because in case of the isobaric process, the addition of the heat, or we can say energy, goes into the heating of the gas as well as the work done. You can say because as the addition of energy goes into heating of the gas and the work done. And now we come to our final part, that is our adiabatic process. Adiabatic process. In this case, work done is given as W3. So adiabatic process means no heat exchange. No heat exchange. Or we can say value of Q is equal to 0. So in this case, the work done comes at the cost of the internal energy. You can say work done comes at the cost of internal energy. As the gas cools down on expansion. So in this case, we can write that our W3 will be equal to P1 V1 minus P2 V2 divided by gamma minus 1. And this W3 is the smallest. W3 is the smallest. So we got the order of our you can say value of W1, W2 as well as W3. So we can write that our W3 is greater than our W1 is greater than our W3. This is the order of the, you can say, work done. And this can be also represented, or we can say in form of graphical representation. So we have pressure and we have two volumes. This is our V1, the other end is our V2. Then the work done, let us suppose from starting from the same point, can be represented by three different curves. Like this, and we can say The topmost curve is our isobaric. So this curve represents our isobaric, whose work done is represented as W2. The middle curve is our isothermal, whose work done is represented as W2, and the lowest one is our adiabatic, whose work done is represented as W3. So this is the basic idea about the plotting of the graph. So if we check the options that are available to us, we can say that option number A is the correct one. So we can say option A is correct. So this completes the question. Thank you.